Section 3.5, linear inequalities and systems of linear inequalities into variables. So, linear inequalities. Step 1, you want to solve for y if possible. Step 2, graph the equation. Use a dashed line if you see greater than or less than. You're going to use a solid line if you see greater than or equal to or less than or equal to. Step 3, you're going to shade above or below the graph line. So you're going to shade above if you see y greater than ax plus b or y greater than or equal to ax plus b. You're going to shade below the line if y is less than ax plus b or y is less than or equal to ax plus b. Another way is if it doesn't go through the origin, use 0, 0 to test what happens to your equation. So as we go to the problems, I will show you what I mean. So example 1 says, graph the solution set for negative 3x plus y less than or equal to 1. Easiest way to do is put this in slope-intercept form. So we are going to add 3x over, and we have y less than or equal to 3x plus 1. So we're going to start the graph at positive 1 on the y-axis. And the slope says, so our m is 3 over 1, which means up 3 to the right 1. So we went 1, 2, 3 over 1, and I put a dot. So next thing I notice, suppose we said our y-intercept is 1, so that's where we started at 0, 1. We said greater than or equal to is a solid line. So we're going to have a solid line for our graph. So just take our ruler and we're going to sketch a line, connecting our dots, put arrows on both ends. So on this one we said earlier that if it's y less than or equal to ax plus b, you're going to shade below the line, which means below the line, to the right of it. Another way to do it is, notice that the graph line did not go through the origin. So I'm going to put the dot at 0, 0. And I'm going to test the point 0, 0. So in your equation that we have right here, y less than or equal to 3x plus 1, plug in 0. So is 0 smaller than or equal to 0 plus 1? Is 0 smaller than or equal to 1? That is a true statement. Since it worked, you are shading below the graph line. So that is where any ordered point in the left to the right of this line, any ordered point to the right of this line will make the equation work. Any number to the left of the equation line would make a false statement. When we look at example 2, it says negative 4y less than 5x. So first thing, divide everything by negative 4. And in doing so, remember, when you divide by a negative involved with inequalities, it changes the direction. So now it's y is greater than negative 5 over 4. And since we don't since we don't have a b value, I'm just going to put 0 so I know where I'm starting. So we're going to say that our y-intercept is going to be the origin at 0, 0 because it's 0. Our m is negative 5 over 4, which means down 5 to the right 4. So this one is going to start at the origin. And we're going to go down 5, 1, 2, 3, 4, 5, to the right 4. 1, 2. And now notice it's a greater than symbol, no line, which means we are dashed. It's a dashed line. So when you take your graph, your ruler to sketch your line, you're going to do a broken graph line. Make sure you have arrows on both ends. Now, in this instance, it went through the origin. So I would suggest you pick up either a point to the above it or below it. So I'm going to test the point positive 1, positive 1. So we're going to test the point 1. That's what we're testing. So when we plug that into the equation, which is y greater than, so we have y greater than negative 5/4 x, and we plug in 1. Is 1 greater than negative 5/4? Is 1, which is positive, bigger than a negative number? That is true. 1 is greater than a negative number, so we are shading above the line. Example 3, it says 4x is greater than or equal to negative 12. Well, I'm looking at my problem, there's no y variable. So when I divide by 4, I get x is greater than or equal to negative 3. Because there's no y variable and it's talking about the x only, that means we have a vertical line because it's an undefined slope. So we're going to plot our dot for our graph line at negative 3 for x. We notice that it's greater than or equal to, which means it's a solid line. And a graph with solid line straight up and down at negative 3. And we're going to put arrows. Well, think about it. This is saying all the x values are greater than or equal to negative 3, which means our arrow is pointing to the right. So our domains are from negative 3 to infinity in this instance. So we are going every number to the right of negative 3 works. When we go to example 4, now we're going into systems. So the first 3 examples we did were dealing with one graph line. Now we're going to incorporate 2. So it says graph the compound inequality, and then it says the form and, which means the solution where they overlap. Where are all the overlapping pieces? So it says y is greater than 1/2 x plus 1. There's our first equation. Our second one says x plus y is less than 1. So the first one's already in, I'm going to number them 1 and 2. The first one already is in slope intercept. So we know that our b is a 1. So at 0, 1. Our m is 1/2, which means up 1 to the right 2. So we're going to graph the first one. Starts at positive 1, goes up 1 to the right 2. And here when I look at it says greater than, there is no inequality sign, so it's going to be solid dashed in this instance. So a dashed line there is no solid line, so we're going to use dashed for this problem. The second one, notice again, it's less than symbol, no line, so we cannot use a solid line. These are going to be dashed lines for both. So I'm going to graph the first one. We have our dashed line. The second one is so here's the situation. Because we graphed the first one and we have our second one to graph, we're going to test 0, 0 since we didn't go to the origin in the first one to see what it's doing. So we have our equation y greater than 1/2 x plus 1. If you plug in 0, is 0 bigger than 1, and that is a false statement, which means I cannot shade below the line. I'm going to shade above the line. So I have a graph. The first one is shading up. You go to the second equation. It says x plus y is less than 1. If I subtract x over, it becomes y is less than negative x plus 1, which means the b is at 1 as well, 0, 1. But the m is negative 1 over 1, which means down 1 to the right 1. So again, it started at the same point as the other graph, but we went down 1 to the right 1. And again, it is a dashed line. We established that. So do a dashed line for the other graph line. Again, it didn't go through 0, 0, so we're going to test 0, 0 in our equation. So y less than negative x plus 1, and we're plugging in 0. Is 0 smaller than 1? Because 0 plus 1 is still 1. And this is a true statement. So it means the 0, 0 works. So we are shading down below the line. And here it said it's a compound inequality, and they want the and statement. Means where is the checkered pattern? So right here, a majority of it is in quadrant 2, is where your solution is. So the checkered pattern is where our solutions are for our system. Example 5 says graph the compound inequality, and it says the OR statement, which means when we talk about ORs, those are our unions. So it means everything. So we're looking at the first one. It says 3y less than or equal to 6, and then y minus x less than or equal to 0. So the first one, 3y less than or equal to 6. We're dividing both sides by 3. So we get y is less than or equal to 2. Which means because it says y is less than or equal to 2, we have a horizontal line. So I'm going to put a dot at y equal to 2. And because it says less than or equal to, we know we have a solid line. So show horizontal means it's running parallel to the x-axis. Put arrows on the end. And it says also on this one that all the values of y are less than or equal to 2, which means it's from negative infinity to 2 is what we're looking at for interval notation, which means the graph line is everything below it. Then we go to our second equation. It says y minus x less than or equal to 0. So if I add x over, I get y less than or equal to x, and I put plus 0 so I know where I'm starting. Because of that, we know that we are starting at the origin, which is 0, 0. That is our y-intercept. And your slope is a 1 over 1, which means up 1 to the right 1. So we start with our point at the origin. And our graph line goes up 1 to the right 1, and we put a new dot. Now it says y is less than or equal to, which means because the line is underneath, we have a solid line again. So we sketch our graph line. Now, because we went through the origin, I cannot use 0, 0 to test. I'm going to pick any point above it or below it. So I'm going to pick the point 3, 1. I'm going to pick this point 3, 1 because it's to the below the line. So I'm going to test the point 3, 1. So you have your equation y less than or equal to x. So 1 less than or equal to 3. 1 is smaller than 3. That is true. So our graph line is shading below the line. So we are shading down. Now remember, we started this problem saying the word or. It means everything. So all of this entire section, this entire graphed and shaded region, everything that's shaded is our solution. All shaded parts are possible solutions.